All right, so for interaction with new material, this is a big problem. We're going to be learning a lot of different vocab and things, so it might take us a little bit longer than normal, but that's okay. So let's work through it. We have these two equations where the x is the input, the y is the output. They want us to first complete the tables, and then on the next slide, for me, I'm going to graph these relations. Remember, a relation is a group of ordered pairs. Everything is a relation, okay? So after we graph it, or before, actually doesn't matter, we need to determine which of these is a function and which is not. And then they want us to, a lot of things we're doing here. We're going to complete the table. We're going to graph it. We're going to determine if it's a function. Then we're going to write a rule for being able to visually determine if a relation is a function. We know how to map it, right? And look for repeating x's, but what if I just have a picture? How can I quickly tell if it's a function or not? We're going to learn that during this problem. So a couple of things I want you to notice. Relation number 1, 2x plus y equals 4. This is called linear. Okay, so this graph is going to be a straight line. How do I know that? My highest exponent is a 1. This over here, y equals y squared. This is a quadratic. How do I know? Because this squared right here. So this will not be a straight line. This is going to be something called a parabola, the graph. Okay, so linear, straight line, quadratic. It makes a U shape called a parabola. But let's fill in what we know. So normally we can just fill in everything on the other side of the equal sign, but they wrote this kind of weird. I'm just going to fix it for you. We're going to write it as negative 2x plus 4 equals y. We'll learn how to do that later. Don't worry about it. So here is negative 2x plus 4. So that's the expression we're going to be evaluating to find our outputs or our y values. So I have negative 2. I'm going to plug in my first x value, which is also negative 2. And then add 4. Negative 2 times negative 2 is positive 4. 4 plus 4 is 8. Next, I'm going to plug in my next x value, which is negative 1. Add 4. Negative 2 times negative 1 is positive 2. I add 4 to get 6, so my numbers are getting smaller. Next, I plug in a 0. Anything times 0 is 0. Add 4 to get 4. Next x value is 1. That's negative 2 plus 4 to get 2. Last x value is positive 2. Negative 2 times positive 2 is negative 4. I add a 4 to get 0. So these are the ordered pairs, x comma y. So this is what we're going to put on the first graph. I'll switch colors to do the next one. So this is our quadratic, so it's going to look a little different. So this time they gave us our y's, and we have to work backwards to get x. And what we're going to do is we're going to take our y value and square it. So negative 2 times itself is positive 4. Negative 1 times itself is positive 1. 0 times itself is 0. 1 times itself is 1. And 2 times itself is 4. So these are the ordered pairs for our second graph. So go ahead, put these on the graph if you haven't already. Pause it here if you need time to do that. So I'm going to quickly graph this. So this is going to be our linear table. Okay, linear means it's going to give you a straight line. First ordered pair was negative 2, 8. Then negative 1, 6, 0, 4, 1, 2, and 2, 0. You're going to use a straight edge. I'm going to do the best I can. I'm going to add arrows because lines have arrows. So this is a actually, we don't know. This is a relation. We're going to figure out if it's a function or not. Let's switch colors to do the quadratic. This will not be a straight line. This is going to be a parabola. which is a U shape. All right, so our first order pair is 4, -2 here. Then we have 1, -1. Then we have the origin, 0, 0. Then we have 1, +1, and 4, +2. So this is what I'm saying when I say it's a U shape. It's not a V. It doesn't come to a point. It's a curve. And make sure you put arrows, okay? Now, what we know so far about a function is that x's cannot repeat, but y's can. This is easier to see in the table, but you can see here that we have 2 x values that repeat. I have a 1 and a 1. 1 is going to +1 and 1 is going to -1. I also have an x value of a 4 that repeats. The x value of 4 is going to +2 and -2. So this would not be a function because the x values repeat. But what's a different way to know that if you're just dealing with a graph? You're going to use something called the vertical line test, okay? So how does the vertical line test work? You draw a vertical line through your graph. And if it only hits the graph once, it is a function. If it hits the graph more than once, then it's not. So using the vertical line test, I can see that my linear function, the vertical line only touches it once. So this means it passes the vertical line test. And it is a function. But my quadratic, this parabola over here, if you notice, it crosses the graph once, twice. So this does not pass, or this fails the vertical line test. Not a function. Not a function. So let's get a definition on this page so that you know what it means. So we're going to write down here, vertical line test. Vertical line test. What do? If you can draw a vertical line, if you can draw a vertical line that crosses the graph in more than one place, then the relation is not a function. Okay? If it touches the graph more than once, 1, 2, not a function. If it only touches the graph once, then you have a function.